Good morning, ladies and gentlemen. My name is Joseph, and I'm the head of strategic solution of Ericsson. Today, it's my pleasure, it's my honor to give presentations to GTI in the GTI events. And today's topic is the power of AI in transforming telecom. That is one of my favorite topics as well. Okay, my presentation consists of three parts. The AI everywhere, I'll be focusing on how we implement AI in the RAN domain. And then Gen AI, I'll share a bit about our best practice in the Gen AI journey. And last but not least, I'll talk a little bit about future, how we define AI native and CSP-based, CSP-centric AI as a service use cases. Okay, when we talk about AI intent to serve the telecom industry, it's better to have a holistic view about the framework. The AI automation framework that we are talking about pretty aligned with the TMF definitions of autonomous network framework, which consists of three layers: the business operation at the top, the service layer at the middle, and the network or resources layer at the bottom. You will see that there are intent closed loop between this layer. AI alone has been working pretty fine for the last few years, within this layer. But when we talk about end user requirement, how to convey this requirement from the top to the bottoms, then we need intents. Intents is a technology, right, that express and distribute end user requirement. You work together with the AI, right? Okay, and this framework that we are talking about which is highly intelligent. We support the closed loop automation. It basically to optimize operators' network to minimize the human intervention. Okay, take a close look to the RAN domain. We observe that the CSP, they invest a lot on various tools, and expertise on RAN network optimizations. But this kind of a methodology, they highly replicable and copies. That's a problem, right? So we observe that they are getting more CSP. They are trying to rely on platform such as the SMO platform that we are talking about. SMO platform stands for Surface Management Orchestration, which is a subsystem of O-RAN, if you're familiar with O-RAN, right? And that SMO architecture that we are talking about, it's a standard, it's an open architecture. Through the introduction of non-real-time RICs, RIC stands for Radio Intelligent Controller, right? On top of it, the RAPP, R stands for Radio Smart Application. Those RAPP can be developed and running on those RIC systems. If you remember yesterday, the afternoon sections, my colleague, Kostova Hollander, calling from Sweden and give a 10-minute speech about EIAP ecosystem. EIAP stands for Ericsson Intelligent AI Automations Platform, right? We try to make this ecosystem, open ecosystem. And in this ecosystem, now at the moment, we have 30 members already. And among these 30 members, 11 come from the CSP, and the rest of it come from independent software developer, right? We are trying to keep it open so that everybody, they can develop high-value, high-intelligence applications to run to serve the CSP. Okay, and the RAPP can work as network planning, construction, the optimization, and network healing, for example. If you look at the right-hand side of the picture, that is a typical example how multiple RAPP can work together to perform complex tasks. For example, one RAPP specific for issue detection, the other for classification, and another RAPP for root cause analysis. And you need a bunch of RAPP for actuation for specific tasks. So this is a typical example. We make network optimization as a platform. And this kind of platform getting popular, I think, by the CSP because it can be copied, it can be replicable, right? So it's good for the CSP investment. Let's talk about Gen AI. We start our Gen AI journey 5 years ago. And it's 2 years before OpenAI released its first GTP applications. So we are not doing a foundation model, but we more focus on training, refining the open source specific for telecom models. Now we have more than 10 telecom specific models, and some of those we open it up into GitHub community. We open it up. And then we invest more than 5,000 expertise to make our own benchmark for testing purpose. So we are invest quite a lot in this Gen AI. And now our technical support team, they are enjoying the benefit from this Gen AI. For example, we use Gen AI search for fast and accurate troubleshoot ticket duplications. It used to be takes a weeks and then reduced to days or even seconds. So that now our technical support team, they can very fast, rapidly to replicate those troubleshooting tickets. It's highly productive. And also, we set the target for 50% of R&D people to use the Gen AI tools. We develop internal coding tools called Coding Buddy, right? So we are exploring Gen AI possibility and its capability in different manner. This is another view scenario reference that we want to talk about. We want to share with you about our Gen AI journey. The left-hand side picture is analytical AI. You can refer it as a small model, okay, small model. This is the real case. We established this small model automated system for Japanese CSP for a couple of years ago. It consists of multiple small models. For example, the small model for normal detections, one small model for predictions, the other for root cause analysis, and the other for recommendation. And this small model, they work together. We set a pipeline, right? A pipeline so that it works in highly automated and minimize human intervention manner. Not only the small model, the pipeline, but also, this model, we need to retrain, right? We also establish MLOps system so that it supports either automatically so that you can set a threshold or manually trigger to retrain those models. And this is a real case. It's a proven AI solution. It has been running stably for a couple of years. We set a MLOps automatically. Automatic AI model retrain the pipeline, and it daily can process as much as 600,000 cells, and weekly it can provide parameters recommendation for 10 to 20,000 cells weekly. It can improve the downlink throughput by 27%. So it's running perfectly. There's nothing wrong with this system, running very good. However, there's a limitations, as I mentioned. Those small models, they are connected with the pipeline, and those pipeline is we establish by the expert. It's a fixed, it's a rule-based. If CSP is picky enough. They are looking for high degree of autonomy, and they are looking for high degrees of adaptive when to the environment change, right? Then they need something more advanced, which is the right-hand side. We are talking about agentics solution. Agentics is a fancy name of Gen AI. We call it agentic architectures. We are also exploring large language model possibility and capability. For example, planning. Planning means we put the large language model in the very core of the problem solving. I mean, the model, it come up a prompt to produce, generate a plan and reasons every single step of the process along the way, right? The model can also call the function or external tools, right, to perform better. And last but not least is a very powerful reflection capability of large language model. Reflection means it makes the model more adaptive to new environment. It can self-learning by itself, and because it enables iterate validation and to modify the environment when the environment change. It modifies its behavior, right? So that the model can work, can perform self-learning and adaptive to new environment. So this architecture is a step-based, means at the bottom, infrastructure, the AI model to the top. We're talking about the application, the AI agents calling the API functions. I'm not going to go through all the detail about these architectures, but I want to highlight both, which is the telco. We are using not the general purpose model, but we use telco specific models. We also inject a lot of expertise, domain knowledge, so that you can call specific tools and functions to perform the network optimization. So the questions now to CSP, the left-hand side, the right-hand side, what model, what architecture you choose. We will recommend that you won't skip the left-hand side in the first place, right? Because the left-hand side, the architecture is running perfectly. That is the technology that you can use it now, all right? Although there's some limitation, but which is very specific, which is designed for very specific tasks, and it works perfectly. You wouldn't all in, I mean, to large language models because there's challenge ahead. I didn't mention that the challenge ahead. Hallucination, that's very common virtually for all models. And we still have some problem of task understanding, handling ambiguity. That means sometimes it performs unpredictable, unexpected. And then if you want to make the large language model use in scale, you need to make it explainable. That's very challenging. So it's not going to happen in these few years, I would say. I mean, these two architectures, they are not conflict each other, right? Actually, it should be from one system evolve to another, right? So the operator, they might invest a lot in the large language model, but to make it work is one aspect. But to make the solutions commercialized, industrialized, that is different aspect, right? So it might take longer than you expect. So our recommendation is you have two architecture running in parallel, right? And one system evolves to another. And the small model in the large language model architecture, it can be called as a function, right? That's our recommendation. Last but not least, a little bit about the future, right? I'm not talking about too much about the AI native in details, but I want to highlight that AI native refers to it's kind of system-defined system design principle, right? Nowadays, we integrate AI into the applications, right? Which is, we call it piggyback, right? But we envision the futures, we will build AI-centric architecture, which consists of multiple aspects. The intelligent everywhere, that means we need to provide the training environment, the learning environment, and the execution environment among the network, across the network, from the left-hand side of the picture to the right-hand side of the picture. You see that the AI model, the MLOps, the AI ops distribute across the network. The data span across the domain, across the different layer that makes, we need to build this MLOps AI apps across the network. And you also challenge for infrastructure data, because when you execute and training the AI everywhere, that means you need to deploy your GPU everywhere. And the network getting more complex, and the model getting more and complex, that we need to manage it in the automatic manner. It comes to the terms zero touch. And AI as a service, meaning those AI, aforementioned AI, not only share internally, but also the CSP can expose it to the external party, so that it could be a new revenue for CSP. I do believe that the CSP, in many use cases, they outperform than HCP when we talk about the AI as a service. This is a typical use cases. We're talking about cobots, cobots running in the factory. They set collaborations, perform automated tasks, for example, smart picking, smart packing. And there are AI algorithms come along to enhance those capabilities. For example, the AI could predict the cobot's locations, right? That relies on the CSP to provide sensing information, the network antenna information, the location of sensor, and those information can only provide by CSP but not HCP, right? And most of the cases, these cobots, they might need to position additional resources. For example, like QoS, and this can only provide by CSP as well. And on top of this, we do believe data and trust, data privacy, some issues like that lead the CSP become or have a better positions than CSP. So to sum up, as time goes by, as towards the journey of 6G, we do believe that the networks will evolving towards AI native, and the AI model not only sharing internal totally for the CSP, but also a new revenue for CSP. Okay, that's the end of my presentation, and I take questions.
Okay, thank you.
Lady first.
您好，我是来自中国移动的孟一路。我想请问一下，咱们这一套系统对于多个厂家场景的这种兼容性如何？
哪个系统？你刚才讲的是
就是咱们这个对生成式。
对，我们想把它做的比较开放啊，所以是刚开始的时候只支持单个运营商，是吧？但后续会有多个运营商的支持，多个网络的支持。但是我们在那个开放性，我们想表达的就是它那个 RAPP， 我们把它做成一个那个类似 developer 的 community， 所以除了 vendor， 除了 CSP， 还有很多不同的那些独立的软件公司可以开发，一起去开发这些 RAPP。我们觉得这个可能是一个 trend。当然，这种 platform， 跟这种专家服务还是有些不一样啊。但是我刚才也提过了，铺人、铺专家这种方式，它很难 copy， 很难对运营商来讲，每年的投入还是挺大的。
谢谢您。
那个我是来自中兴的 Jason， 那我快速的请教个问题，我看到咱们这个平台，咱们昨天下午也介绍过了。
哦，对。
好像那个咱们那个 RAPP 实际上 stand for the radio application，right？
啊，对，因为它是基于 SMO 设计给无线的那个自动系统。
为什么只考虑无线？没有，因为我理解很多的时候会至少要 including 核心网吧，就是有
对
一些。
讲得挺好的，因为今天我只是 focus 在那个 RAN domain 是吧？如果我们说核心网，其实那个 TMF 的那个 autonomous network 它是 cover 那个所有整个网络的啊。我今天只是比较 focus 在 RAN 这边。
OK， 然后我有印象中，咱们爱立信实际上就有一个公司叫 Vonage， 就是那个 Vonage 它实际上也是通过 API 把一些网络的能力开放给一个开发者社区。
对。
那这个和我们现在这个平台它是一个什么样的关系呢？
这个问得非常好，因为我发现很多对我们还是有一点点，或者说我们表达的不是很清楚啊。其实都是叫做 API， 但是一个叫网络的 API 就是 Vonage， 对吧？比如我们一些手机软信，比如我们一些 telecom 的一些 API， 但是我们今天讲的 SMO 这个是基于 SMO architecture 里边的 API 调用的东西是不一样的。
OK， 好，谢谢。
Thanks very much. I hope these are quick. First of all, I know you reference small model and so on, but in the challenges, you agree still, especially in the mobile environment, still the size, storage, memory, as well as latency will be a challenge, especially with a large number of users, and if you want to personalize. So that's one question. The other one, when you talk about CSP and support and evolution chart you had, I guess one of the attributes is this collaborative training and collaborative offloading, inferencing split, right, between the network, the edge, and the device, depending on the situation. I think that would be an important part of why we need network assisted, right? So those are my two questions. Thank you.
Yeah, very good comment. It's not a question. I agree with you. Totally agree with you. That's why we quite believe that the HCP, they have their market. The CSP, we have different market, right? And this market, we share different segment, right? CSP, in that case, cobots, I do think we have very strong advantage and good positions in that. Thank you. Thanks for your comment.